Hello and welcome to day 19. This time of year, it kind of seems like we're starting to get over the hump and the puzzles start to get a little bit easier. Given how yesterday was easier than the day before, hopefully that's happened, but we'll see. All right, scans show the lava did indeed form obsidian. The wind changed direction enough to stop sending lava droplets towards you, so you and the elephants exit the cave. As you do, you notice a collection of geodes. Perhaps you could use the obsidian to create some geode cracking robots. Collect the obsidian from the bottom of the pond. You'll need waterproof obsidian collecting robots. Fortunately, there's an abundant amount of clay nearby. In order to harvest clay, you'll need special-purpose clay collecting robots. To make any type of robot, you need ore, which is plentiful. Opposite direction from the clay. Collecting ore requires ore collecting robots with big drills. Fortunately, you have exactly one ore collecting robot in your pack you can use to kickstart the whole operation. All right, so that's our potential first set of data. Each robot can collect one of its resources type per minute. It also takes 1 minute for the robot factory, also conveniently from your pack, to construct any type of robot, although it consumes the necessary resources available when construction begins. What factory has many blueprints you can choose from, but once you've configured it with a blueprint, you can't change it. You need to work out which blueprint is best. For example, okay. Blueprints have been line wrapped here for legibility. The robot factory's actual assortment of blueprints are provided 1 blueprint per line. 1 blueprint per line. I see, so that's not actually the sample data. Sample data actually should look like this. Let's make sure they're all in the same order. Ore costs ore, clay costs ore, obsidian costs ore and clay, geode costs ore and obsidian. Okay, so they're all in the same order. So let's go drop this here. Okay. I'm starting to look hungry, so you shouldn't take too long. Geodes after maximize the number of open geodes after 24 minutes. Using blueprint 1, the largest number of geodes you could open in 24 minutes is 9. One way to achieve this is 1 ore collecting robot. 1 ore collecting robot collects ore. You now have 2 ore. Spend 2 ore to start building a clay collecting robot. 1 ore collecting, okay. New clay collecting robot is ready. You now have 1 of them. 1 ore, 1 clay. Spend 2 ore to start building a clay collecting robot. 1 ore collecting, yep, okay, 1 clay, sure. Three ore and 14 clay to start building an obsidian collecting robot. 1 ore collecting robot. It's 1 ore, you now have 2, sure. And to build a geode cracking robot. 2 ore and 7 obsidian to crack geode cracking. So 1 cracked. Geode cracking, 1 cracked. You could do it even better. The largest number of geodes you could open in 24 minutes is 12. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened in 24 minutes. In this example, quality level is 9. Second is 2 and can open 12, so its quality level is 24. Add up all the quality levels of all the blueprints in the list, you get 33. Determine the quality level of each blueprint using the largest number of geodes it can produce in 24 minutes. What do you get if you add up the quality levels of all the blueprints? Well, so much for thinking that today would be easy. So fair enough. Let's do our regex. All right, so we have this. This is going to be D plus, D plus. Okay. Gonna go look at the real data and make sure we don't have any changes in verbiage. Costs, 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 ore and clay, ore and clay, ore and clay, ore, costs, ore and obsidian. Okay. So that looks okay then. So the real question is this pattern that they're using here, which is basically, you're trying to get to building a geode robot as quickly as possible, which requires obsidian, right? Which means you want to get to obsidian as fast as you can. Obsidian requires ore and clay, which means you need to get clay as fast as you can so that you can build it. Each ore robot costs 4 ore. What's interesting is they never bought another ore robot. But they ended up buying 3 clay robots, 4 clay robots, 2 obsidian robots, 2 geode robots. What is going to be the best strategy for figuring out how many of these things we need to buy? I don't have an obvious answer off the top of my head on that one. And obviously we could just run a simulation where we max out more ore, more clay, more obsidian. Don't know. The data, whoops, I want the real data. I don't know why I was looking at the program. I want the real data. Clay is always the most expensive part of this. So it's safe to assume that we probably need to build more clay robots than ore robots. But like in this case where we have one robot, an ore robot costing 2 ore versus a clay robot costing 4 ore versus 4 and 4, this may want us to make more ore robots because that will mean we can get ore faster. If we get ore faster, then that means we get clay faster, right? Right. So it's kind of like, hmm. Regardless of the cost, each robot only does one thing every minute. So interesting is that here clay is about 5 times more expensive than ore, which sort of, well, is that true here, right? So the obsidian robot here, yeah, it's roughly 5 times more expensive, which means you probably want roughly 5 times as many clay robots as you want ore robots. Multiplying that blueprints. All right. Really kind of about optimization, right? Really kind of about optimization. The best way to optimize this. So interesting that they give us the instructions for the first set, but they don't tell us how the second set gets to 12 in 24 minutes. Is there a way, cost rations? Yeah, I assume you mean ratios. Yeah. Yeah. I'm trying to think about ways that allow me to shortcut, just big old loops. Hmm. Yeah. Not really sure. Part of me is tempted to just write the loops and see what happens, just so we can make some progress to see how bad it actually is, right? All right, so every one of these needs to be, let the match to be regex match the line, right? And then we select we want or to be match groups one value. This is going to be int parse. Let's at least get the parsing done, right? So the OR's cost is this in OR. And then the clay's cost is this in OR. Did I close too many parentheses? Yes. Which means I closed too many parentheses here, I think. Let's see, 1, 2, 2, 1, that's okay. 1, 2, 2, 1, that's okay. Tuple must contain at least 2 elements, so you can't have 1 element tuples, huh? Fine. So that's the clay's cost. Okay, and then we've got Obsidian has a cost of ore, right? Ore is this, which would be 3, and clay, which is this, which is 4. All right, let's kind of want to spread these out so they're readable. Yeah, okay. All right. At which point we have then geodes cost in ore is 5, and in it's ore and obsidian, right? Ore and obsidian. So that's match 6. Okay, so I think that's it. For each var item and data, console right line the item. Let's make sure we're parsing everything okay. Apparently tuple must contain at least 2 elements. Yeah, okay. Now what? One, 2, 1, 2, 1, 0. That's obsidian, by the way. 1, 2, 1. Let's see, 1, 0, 1, 0, 0. I don't see what the problem is here. 2 array. Am I just missing a parenthesis? I'm just missing a parenthesis. Okay. So 1, 4, 2, 3, 14, 2, right? Oh yeah, this is wrong. This is we also need the ID, which is actually this. All these are off by 1, 2, 3, 4, 6, 7, and 5. So 1 is 4, 2, 3, 14, 2, 7. Is 4, 2, 3, 14, 2, 7. Looks good. Okay. So given that, for each var blueprint in data, we're going to say the minute is start with minute 1, and we finish after minute 24. All right. And we need, let's see, ore count or machine count is also 0, right? The clay count is 0. The clay machine count is 0. This, by the way, is 1 because we do start with one of those. Obsidian count is 0. Obsidian machine count is 0. Geode count is 0. Geode machine count is 0. So we'll do this. Our minute is 1. Minute is less than or equal to 24, double plus minute. For the moment, ore count plus equals ore machine count. Clay count plus equals clay machine count. Obsidian count. Obsidian machine count. Geode count. Geode machine count. So I think what we want to say is, like, what is the dumbest version of this that would work? If we have, Let's see if obsidian count is greater than or equal to geode, let's see, blueprint geode obsidian, and ore count is greater than or equal to blueprint geode ore, then we definitely need to buy an obsidian machine. Right, and then our, this is probably a case of while, but we'll see. So while that's true, we do that, and then ore count minus equals blueprint geode ore, and then yeah, obsidian count minus equals blueprint geode obsidian. I think if I make these all like this, then I'll be able to use a generic buyer kind of a thing. Or clay 0, obsidian 0, or clay obsidian 0, clay 0. We could do void by, we'll do ref int ore count, ref int clay count, ref int obsidian, come on, int obsidian count, ref int machine count, and then we pass in this int ore, int clay, int obsidian. Why are you a semicolon? Machine cost. I will say, well, while we can buy these machines, we should, right? So while ore count is greater than or equal to machine cost ore, and clay count is greater than or equal to machine cost clay, and obsidian count is greater than or equal to machine cost obsidian. All right, then we say the machine count double plus, and we say the ore count minus equals machine cost ore. And clay count minus equals machine cost clay. Obsidian count minus equals machine cost obsidian. All right. And then here we want to say buy. Right, we want to buy obsidian, we want to buy geode machines first. So this is ref ore count, ref clay count, ref obsidian count, ref geode machine count, and then blueprint geode. All right, we want to do this over and over again. So we want to do this with geodes and then obsidian machines. And then clay machines. And then ore machines, or machine count. Or well, let's say print the day, print the minute, which is this minute with our ore count, our clay count, our obsidian count, our geode count. That should be enough to get started. Print minute int ore int clay int obsidian int geode. Console write line minute. If ore is greater than 0, then console write line ore on hand is ore. 1, 2, 3. So this is clay, obsidian, geode, and then this is obsidian, and this is obsidian, and this is clay, ore. Now, I want to make sure that I can buy as many robots as I want each day, right? Spend. There's a bunch of time in here that's spent not spending. One thing I notice here is that well, let's just run this. I'm sure this is going to have the wrong answer, but I'm kind of curious to see what we end up with. So we have no ore, we have no ore, we have no ore, we have no ore, we have 1 clay, we have 3 clay, we have 6 clay, we have 2 clay, we have 6 clay. I think I want to, where do we end up? We ended up at the end of 24 minutes with 29 geodes. Really, we ended up with 29 geodes? Really? Really? We ended up with 29 geodes. That's more than they did. They ended up with 12. No, they ended up with 9. How'd they end up with 9? How did we end up with ore, clay, and obsidian? All right. Console write line. Buying name machine for what is it? Machine cost. Machine count. So tell us exactly how many of these we have. How about we just write these all the time in one big line? And then geodes. And if we're going to do that, we might as well just come down here and do it here. except of course we need the word count in front of everybody. No. All the buys need names, of course. Geode. Obsidian. Clay. Or. Okay, so let's go up to the top. So we bought a clay machine. We have nothing left. We have 1 ore and 1 clay. Buying our second clay machine. 1 ore, 4 clay. Buying our third clay machine. 0 ore, 6 clay. Buying our fourth. So we just keep buying clay machines. This is what I was worried about. 25 minutes we had no geodes, but we had 132 clay. That's really not what we wanted. How about this second time? What happened here? We bought ore, we bought ore, we bought clay, we bought clay, we bought clay, we bought obsidian, we bought clay, we bought obsidian, we bought obsidian, we bought clay, obsidian, we bought geode, obsidian, obsidian, geode, obsidian, geode, geode, obsidian, geode, geode. 23 geodes. We bought the obsidian machine, 29 geodes. Why do we get 29 here? They claim the best we could do is 24. That's very curious. Or 12. They actually say the best they could do is 12. All right, so we need some logic to say when it's reasonable to save and when it's reasonable to spend. Let's try a really dumb one, which is only buy old things before you buy the new things. All right, that's a really dumb strategy. That's clearly not going to work. But here we seem to end up with 18 geodes. And what about up here? We ended up with no geodes. We just ended up with clay forever again. Thinking about this, the maximum of any machine we can get is 24. If we optimize are we, first of all, let me make sure I'm incrementing all the counts correctly, right? Geode, geode, obsidian, obsidian, clay, clay, ore, clay, obsidian, clay, obsidian, clay, obsidian, clay, obsidian. What if we try to go backwards to try and solve this problem? Right, if we try to go backwards, we could say, let's let's start assuming we can make 24 obsidian machines, which we obviously can't, but let's assume we can. What do we need to do that? And then work our way backwards from that, right? So if we were going to need we would need 48 ore and 7 times 24 obsidian. How does that help us though? I mean, these like Hal's suggestion, which is I think pointing out what I was talking about earlier, which is ratios are definitely part of this, I think. Right, we know we need, in order to get obsidian robots, we know we need to be making clay about 5 times as fast as we're making ore. And we know we need to get geode machines, we need to be making obsidian, 3 times faster than ore. How does that factor into this? And will I be reading too much into it? All right, so if I'm here, I say, I know that I want roughly I need roughly 5 times as much clay as I need ore. So how many clay machines does that mean that they buy? They buy 1, 2, 3, 4, 5. I also noticed they only buy 1 machine per minute. Does that mean I can only do 1 machine per minute? That must be why I'm coming up with numbers that are larger than theirs. Each robot also takes 1 minute for the robot. Oh, so there's only 1 robot factory. So I can't buy multiples at the same time. Right? This is not while, this is if. So we can do this, which is, hey, if I didn't buy one of those, and I didn't buy one of these, and I didn't buy one of these, then we definitely want to buy one of these. Even though that's not necessarily true, let's at least see what it does. One. So we got a machine, we got a geode machine up here at minute 14. Here we just end up with a bunch of clay and no obsidian. Because we never end up buying another ore machine, which I think is okay. So here's our first geode machine. We bought it here, we collected it here, we collected it here. We bought it here, collected here, collected here, collected here, bought another one here. collected here, 14, 18, 20. So we still have 29 geodes. All right, so back to my ratios. Each ore robot costs 4 ore. Yeah, all right, that's fine. So my ratios, let me get these written down here. Okay, so the ratios, let's see, obsidian is 14.3. Well, I guess we can just write in 314, right? So geode is 3 ore, 14 clay, ore, and a geode is 2 ore, 7 obsidian. So this is a roughly 5x, and this is a roughly 4x. So when I look at this, I say, spend 2 ore to start collecting clay. So ore is 1, clay is 1, and then another one for clay, and then another one for clay, and then another obsidian, then an obsidian, and then a clay, and then an obsidian, and then a geode, and then another geode. That's it. And that's how we got 9 geodes with 2 geode robots. Okay, so that ended up being 9. So clay ended up being about 4-to-1 over ore, which is approximately where we are here. And then obsidian was about 3-to-1 over ore, which is about what we are here. But the numbers are so small that I might be reading more into it than really matters. So you're telling me that there's no way I can get better than this. Obviously, I want to buy as many geode machines as I can, as quickly as I can. Largest number of geodes you can open in 24 minutes is 12. I'm also curious why. What rule did I violate here that allowed me to get to 29? And what are my ratios for that one as well? So my ratios for that one are, let's see, so clay is 1.5x, obsidian is 1.5x, or obsidian is 8/3 would be, 266 versus ore, and geode is 4x, or obsidian versus ore. This is clay versus ore. So they don't give us the second example. They just tell us we could do 12. Right, our goal in order to be able to be making obsidian is to be collecting that much more clay than ore. And our goal to make geodes is to be able to collect that much more obsidian than ore. Ore machine count. Right, let's see the machine counts. That's the clay machine count. That's the obsidian machine count, and then that's the geode machine count. So there's probably going to be a point at which we say, what if we start with one ore machine and never buy ore, right? And so my guess is if we follow whatever the rest of the strategy is, let's say that's the current strategy. There will be a point at which, based on that decision, we'll start going down again, right? So what if we do that all across the board? What if we say we set a target for the number of machines? And of course, our target for geode cracking machines is as many as we want. So let's try this then. For our ore machine target is one ore machine target is less than 24? I mean, sure. What if we do this all across the board, right? Actually, we only need 3 because we need clay and then we need obsidian. These can obviously go down because you can only buy 1 machine per day. So these numbers are going to reset here. And then we're going to say blueprint best will be 0. Right? And then for every minute, we basically want to say if our ore machine target is greater than our ore machine count, bot is false. Let's try and buy an ore machine, right? So if we haven't bought and our clay machine target is greater than our clay machine count, then we're going to try and buy clay. right, and then we'll do this again for our Obsidian machine target and our Obsidian machine count. And we're going to buy Obsidian machine if we can. I want to put not bought here, even though it's fine, because I might want to reverse these around. In fact, I think I'm going to. Like, I want to put Obsidian first and then clay. And then we'll do up top. Obviously, we still think that we should buy. Actually, we'll just try and buy geode. If we can, we should. I think we agree that that piece of logic is unimpeachable. This stuff has to happen before the buys. Let's see what happens here. Let's not write this. Let's not write this. Let's instead, at the end of all of these, right, so at the end of all this, we're going to say if the geode count is greater than blueprint best, then we're going to say console right line improved to geode count. And then blueprint best is the geode count. I think there's a point at which we go back down that we stop. Oh yeah, we want to stop buying. Oh, I want to stop printing out buying, sorry. So it looks like we got to 18 and 29. So once again, I'm led to wonder, how did we get there? Because the fact that we see these things at very different number than they do, have 9 open geodes. Like I need to see the logic that got us there. Did we ever get 9? Did we ever get 9? We never even got 9. Or if we got 9, we got it after we got to 10. What if we do this, which is blueprint steps is a string builder. Our blueprint best description is an empty string to start with. So let's do blueprint steps as a string builder. Blueprint steps is going to go into the buy. So we can record the steps so we can see how we got here. Right, then we're going to do blueprint steps append line. All right. And then we're going to do blueprint steps append line. Nice empty line. This is going to be blueprint steps append line. What's the other thing they print out, which is they print out all of this. One ore collecting robot collects one ore, you now have one ore. All right, so if ore machine count is greater than 0, which it always will be, we'll do this and we'll say blueprint steps, append line, collected ore machine count ore for a new total of ore count. So we want to do this for clay, 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 clay for clay count. All right. And we're going to do obsidian and geode. Obsidian, which is a word I just cannot type. Obsidian, obsidian for a new total of obsidian count. And then geode, geode count, geode count, geode count, geode for a new total of geode count. Okay, so then the buy needs the blueprint steps. Blueprint best description is blueprint steps toString. I don't think I need this. What I'm going to do at the end is I'm going to console write console write the blueprint. Come on, blueprint best description. Except I guess I want that here, right? So the buy needs a blueprint, needs the string builder, steps, append line, buying blah machine for machine cost. Okay. Let's see what 18 gives us. We got to go all the way up to the top. Right, how's this going to look compared to the description over here? Collected ore, so now we have 1. Collected ore for 2. You have to spend before you collect, because I'm spending after I collect. That could explain why I've got a different number than they do. Also, I kind of want to just do 1 blueprint for now. Let's try and get 1 there. So we have to spend before we count. Okay. I don't think I need that. Well, I'm going to leave it there, but I don't think I need that anymore because I'm seeing the numbers elsewhere. All right, so we got a total of 18, which is more than they came up with. They came up with 9. So let's see what I've done wrong. So they collect 1 ore for 2, buying a clay machine. They collect an ore and a, oh no, you can't collect the clay yet. This is the problem, right? So you have to spend, but you can't collect yet. Great. That just means I need to count all the old values. It's going to be ore count, clay count, ore machine count, clay machine count, obsidian machine count, and geode machine count, right? Then you buy, and then you say old dot. And we use old, 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 old. Okay, let's see how it looks now. So now we end up with 8 as our best, which is getting us closer, but let's at least make sure that we're following the rules correctly. So there's an ore for 1, an ore for 2, a clay for, and a collected ore. Right, and then we collect ore, collect clay, we buy clay, we collect ore, we collect 1 ore and 1 clay, we collect 1 ore and 2 clay, we spend 2 on a clay collecting robot, collect 1 and 2 for 1 and 6, collect 1 and 3 for 2 and 9, we collect 1 and 3 for 2 and 3 and 12, collect 1 and 3 for 4 and 15, we buy obsidian for 3 and 14. We collect ore and clay. We did not buy a clay collecting robot here, which is kind of interesting because we have enough. We have enough to have done so, but we didn't. And this is where we diverged. And so you think this is the best because of 8. But we know the best is supposed to be 9. Did I do something wrong with the logic? Ore, clay, 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 obsidian, obsidian, obsidian. We always want to buy geode first. Then we want to try and buy obsidian. Oh, we forgot to record bought it here. Don't know if that matters. Can we get to 9 now? No, we're still only getting to 8. Still only getting to 8. All right, result plus equals blueprint.id times blueprint best. By geode collect. Is the problem that I'm always preferring obsidian over clay? Maybe that is the problem. Because if we are trying to hit a target, right, if we're trying to hit a target, maybe we should go in order. If not bought, then we try and buy. Right, at which point We put obsidian down here, and we put ore up here. Is that why we don't hit the max? No, so we still hit 8. The assumption, though, is that we would always prefer to buy the lower level machine until we hit our numbers, which I guess is a reasonable assumption. I mean, the reality is this example, we had 1 ore, 4 clay, 2 obsidian, right? So let's set a breakpoint here for that condition and see how that plays out. Actually, yeah, let's set the breakpoint here. And so it's ore of 1, clay of 4. Let's see, ore machine target is 1, and the clay machine target is 4, and obsidian machine target is 2, right? That's what I think I counted. All right. So this is 1, 4, and 2. So the geode count here is still 8. And then in the immediate window, let's do a blueprint steps toString. Actually, let's put that in a watch so that we can inspect it. And let's see how we did it differently than how they did it. Because I can see another set of variables here, which is, yeah, I can see another set of variables here, which is that we, oh, okay, you don't want to come out? Fine. Put you in Notepad then. The buying order matters, and the buying order can't be fixed, like the buying order preference can't be fixed here. All right, anyway, this is this, so let's go see this. So ore, clay, we buy clay at 3, we buy clay at 5, we buy clay at 7, we bought clay at 9. This is the problem, right? Like we ended up buying clay too early. And the interesting problem there is like we spent clay right after we did obsidian. So what happens when we reverse these again, right? And then we do this, which is yes, view it, copy it, paste it. So we bought clay at 3, we bought clay at 5, we bought clay at 7. And then we waited for 11, but we still ended up buying clay at 7, even though we preferred obsidian, because we didn't have enough for obsidian at that point. And then we bought clay again at 9. And that's how we got to maximum clay. Yeah, there's something. Like in my head, I could see the possibility of basically saying for every one of these scenarios, also then every time we buy a machine, just say, try the next machine that you buy being X. Yeah, I'm not sure how to do that. I mean, I could do that with a loop, but I'm not 100% sure what is the right answer for this. What can we find with a quick Google, do you suppose? Optimizing resource allocation in a game to maximize profit. Enterprise key resource allocation. And utilization of collaborative intelligence in an evolutionary game. This is a long paper. That is not really what I'm looking for. Game theoretic resource allocation. Marketing. Not even sure that I know how to Google for this yet. Let's see. Game theory to maximize construction profit. Game theory, okay, how game theory strategy improves decision making, game theory, Investopedia, yeah, okay, that doesn't really work. That's just all game theory stuff. Hmm. Really don't have a good video game maximize construction profit. What is this? Yeah, so this is like for people who want to make money with video games. If I knew what this thing was, maximize resource production video game. How can a resource, maximizing resource production, infinite Lagrange wiki. Improve resource harvesting and how to increase your resource productivity in Mafia City. How to maximize resource production in Stellaris. State of survival tips to maximize resource farming. State of survival is a game name. Okay. Let's see how to. Yeah, so this isn't helpful. This isn't helpful. We know we're after 9, that's fine. That's not what I wanted to do, that's what I wanted to do. What if what I do at every step is I try all 4 versions, which says your next buy should be whatever, right? That's really what I'm after, isn't it? So instead of this, right, let's run that out and this out. So for every blueprint, I want to basically say, if, let's see, we'll do this, which is potential, best is 0, potential is next machine is. So I kind of want to start putting this all in a class, I think. Game state. Which is going to be this stuff, basically. Wow, did I really? All right. Public or count. Wow, why did you get lowercase there? That's weird. Okay. Public int. We'll make you guys uppercase. All right. And then public game state clone. Return a new game state whose or count is our or count, etc. Think or count, machine count, clay count, clay machine count, sitting count, sitting machine count. Obviously, we were 1 off here. Oh. I don't know if that's all the state, but we'll see. So the state is new game state. All right. And then out of next machine is, we'll get more game state. So from this state, we would like our next move to be or yeah, okay. best is less than potential dot geode count, then best is potential dot geode count. Actually, let's do best. Let's do game state. Best is null. And if best is null, or best geode count is less than this, then best is potential. And then we do this 4 times. So we got ore, we've got clay, obsidian, and then we do geode. And I guess we'll keep the blueprint steps in here. Public string builder steps is a new string builder. All right. Which also means that steps is a new string builder based on the existing steps toString, right? Yeah, I'm not 100% sure exactly how I'm going to write this yet. Public game state next machine is game state string resource type. What we could do is we could say we also need to know where we are in terms of the minute, right? So we're going to start on minute 1, which means minute is something we need to get copied. And then I think what we want to do here is, no, you don't need to be public. We want, yeah, we'll use reflection to get the properties that we want. All right. We also need a blueprint that we're working on, don't we? Yeah, we need the blueprint we're working on, which is that thing. All right. I need to take a quick bow break. I'll be right back. Whoops, that's not what I wanted. That's what I wanted. Okay. Actually, we don't need to use reflection for this. We can do a try by with a string, and the string can figure out what we're going to do with it, which is fine. Yeah. No, that's too much, apparently. Yeah, you don't need a semicolon. That's just too much. Public bool try by string name. If name is or. Let's say we can do, yeah, else if name is clay. Oh. Else if name is obsidian. Else. It's fine, right? Try by, then collect. That's what we'll do, then collect. Collect. Everybody gets to collect. So this is our collect. Actually, we don't need to collect. What am I talking about? Right? And then we want this. Steps. Steps. Clay count. Steps. Clay. Result is false. Return the result. Cut it up. Cut it up. Obsidian count, obsidian count, obsidian count. Steps, steps. Obsidian, obsidian. Geode, geode, geode. Man, if this is this complicated, I'm really wondering what the heck part 2 is going to be. Okay, so there's that. So if the name is or, then basically we want by. Right? We want that. over and over again. Actually, let's just put by right there. Try. We'll just make you try by. I don't need that. I do need the name. I don't need any of those. I do need that. And I do need that. Buying that for that. That goes down. Turn true. Turn false. Result is equal to try by. So the name, the machine count here is ref or machine count. And the machine cost is the blueprint.or. So we also need the blueprint. Right, and we know that this is the blueprint, is this whole thing. Do I have an easy gesture to turn this into a type? Convert to record struct. Yes. Blueprint. Okay. Sure. So we need a blueprint. Public blueprint. Right, which means our constructor needs the blueprint. Blueprint is the blueprint. Constructor goes above those. So you need that. Result is try by name ref clay machine count. Blueprint clay. So you're the obsidian machine count, and you're the obsidian. Otherwise, you're the geode machine count, and you're the geode. So if we did buy, we put it into the steps, which is good. So try by then collect, which is public. Okay. So this is the blueprint. And we do this. Right? And then at the end of that, we're just going to print out the results, which is best steps, toString. And then this is this. Don't need you anymore, breakpoint. Best geode count. Okay, so given this, what we want to do is, given the game state, Right, what we want to do is we want to say, given the resource type, we're going to say while true. Actually, we'll say while state minute is less than 25, because that's really our exit criteria. We're going to say try by then collect for our resource type, bought. Then we're going to say if you bought it, then we're going to do the same thing here. Right. Then the best is this. And we're going to do state clone for each one of these and say try this. Right here, we're going to do a return best. That's our recurse. And if we get to the end, then we would just return our state. Okay, I think that should work. Let's see what happens here. I mean, typed a lot of code. The fact that it doesn't even build is hardly a surprise, right? Come on. So all that is true. Okay, do you just build now? All right, you build. Okay, let's run. We run out of memory? Is that what happened here? Expand by a block, try by. Oh, you know what? We never incremented the minute. So up here, state minute plus plus. So we're never getting out because of minutes. This is really expensive. How about this? Let's do this. Console write line finished for state geode count with ore machine count, clay machine count, obsidian machine count, geode machine count. How about that? Let's make sure we're actually finishing. Finishing a lot with nothing. This is really unexpected. Especially given this. I guess. I mean, I don't know. If state geode count is greater than 0, then we're going to do that. Otherwise, we're just going to do console write a dot. We got some ones. So here's the interesting question. What if we went backwards? Right. With this, would we be able to cut our problem space at all by going backwards? Don't know. Oh, you know what? These all need to be cloned, don't they? Or they can just be new. They don't have to be clones. Because of course they each need a clean game board, right? The other thing we're missing is state, steps, append line, minute, minute, state, minute. That was the other thing we're missing there. Well, we definitely didn't start at the top. We're getting some fives. I don't know how many of these I expect to run per blueprint, but this is just one blueprint, and I know our sample data has a lot of blueprints. Right? Our sample data has 30 blueprints. So whatever this takes to run one, it's going to be times 30. I mean, what I can tell is that it's not slowing down, which is good. And if I look at RAM consumption, you sit underneath Visual Studio, right? Day 19. So we're basically consuming a core and fairly constant RAM, which is not, well, we stopped consuming any CPU at all. Maybe it's time for me to stop printing things and just let it run. And we'll see what's going on here, right? Day 19 is using a core, fairly constant RAM. This isn't going to be the right solution long term. I don't think. So it took me 24 seconds to get 9. Let's try blueprint 2. That should give me 12. Is it going to be in roughly 12 seconds? I mean, I could multi-thread this, right? I am, like every time I'm calling this function, I could do it in a thread. Because every time we call ourselves, we get a clone. So we shouldn't have any shared data. Yeah, I think we're done with you, I think. Yeah, I think we're done with you. What did we say it was, 24 seconds? God, 24 seconds seems like a long time. Don't know why this one would be taking so much longer. Fundamentally, it's exactly the same. Visual Studio, where's Visual Studio? Day 19, we're still running. All right, let's go back to having just one blueprint 1 to start with. Let's see if I can multi-thread this. So this is going to be a task of game state. Return, await. Now we're just return. We don't need to be async. Return, task, run. You need to be async. All right. Variables captured state and resources. Async method lacks await operators. Right. So this is going to be await, 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 await. And then return state needs to go there. Okay, so then everybody here, you need to be async, right? Async task of long, get part 1. You're going to be a wait, and a wait, and a wait, and a wait. And you need to be a wait there. Am I going to be allowed to do that? Yes, I am. Okay, good. Let's see what happens with Blueprint 1. Let's see if we get better CPU usage now. Visual Studio. Looks like we're getting 2 cores. Maybe. What does that look like? Yeah, 25%. Guess that's a little bit better. I don't know. It took a full minute. Did it take 24 seconds or did it take something and 24 seconds last time? All right, well, let's run. See, is there any way to show like clock needs an update? We're getting the update ready for you. First of all, I didn't even know there was a clock app. That's fair. I would really just like to see you tick. Is this the most ludicrous thing that I've seen? Possibly. Nope, nope, this is the most ludicrous thing I've seen. Timer. Nope. Stopwatch. Having to log in to use a stopwatch is definitely the most ludicrous part. All right, go ahead, run. Start. So we know how long a minute is going to take. So we're not sitting here guessing. And then we're also going to find out whether part 2 is also going to take a minute. I mean, clearly if everything takes a minute and I put in the data for 30, then half an hour from now, I can get the right answer. But brute force isn't going to work, and part 2 is really going to be horrible. So there's a minute. Because of course I was slow to get started. Interesting, this one's taking longer than a minute, isn't it? But that's what we were noticing before too, is that it seemed like this one was taking longer. Why do you take longer? You should be exactly the same, right? Maybe we have more opportunities to buy. So every opportunity to buy means a bifurcation. Wow. So we can't even count on it being a minute. Hmm. Wow, this is worse. This is a lot worse. I'm curious to go look and see if anybody I know has already finished it. Yep, definitely know someone who's already finished both parts. Holy smokes. Well, this isn't working. I mean, if I could have assumed that these things would take a half an hour for 30 of these, then I would let this go, but that's not even an assumption we can make. Um, yeah. I don't know. At this point, I really don't know. I'm kind of out of ideas. This is the brute force idea, and there's just no way this gets done in time. So there's something about how you're supposed to be picking these things that doesn't work. I am curious. I mean, I'm going to take the minute because I'm an idiot and didn't save it last time, but I'm going to take the minute to give me one and make sure that even though I got 9, which is the right answer, I kind of want to make sure that I got 9 the same way that they got 9. So it's possible that there are multiple ways to get 9, but we'll find out, I guess. And maybe in this minute, while I think dark thoughts, something better will come to mind. Okay. So minute 1, collected ore, bought clay, collected ore for 1. Collected, bought clay for 1, 2. Collected for 2, 4. There's minute 7. Minute 7 is bought clay, collect 1, 6. Collect 2, 9. Collect 3, 12. Collect 4, 15. Buy obsidian. Collect 2, 4. collect 171 after buying clay. All right, 13 is just collect, 211, 2, 315, 3, 154, but we bought obsidian, so now we've got 296, we've got 313, 8, we've got 217, 3 after buying geode, which means we now have 321, 5, 1. We have 425, 7, 2. We bought geode, 329.23. We collect for 433.45. We collect for 537.67. We collect for 641.98, and that's it. So we got the right answer. 100% got the right answer through brute force. But I really couldn't tell you how to do it better. I don't enjoy the fact that 4 times now we have ended up finishing the video before I'm done with the problem. Even though the other 3 times I've gotten an answer on part 2 and finished part 1. And now we're stopping without even finishing part 1 because we just don't have the time. I don't think we have the time. I mean, if I can't think of anything before I go to bed, I'll put all the data in and I'll let the thing run overnight. And I should get an answer. Yeah. Anyway, got nothing. Sorry about that. It's just going to be another one of those days, I guess. So I'll see you tomorrow.